Okay, welcome in. Glad you made it. I'm going to go through an example on the Pythagorean Theorem, and I've got it spelled out there for you. Don't worry, I won't assess you on that. The Pythagorean Theorem says that a squared plus b squared equals c squared. Well, what does that really mean? So what we're talking about are sides of a triangle, and not just any triangle, okay? So this triangle that we have here has to be a right triangle, so it's got to have a 90-degree angle. And I'm going to mark this as the little box. That means that it's 90 degrees right there. And then the other angles together in the triangle will add up to 90 so that all three are 180, just like we've done in geometry this year. All right, so why does that part matter? Well, this Pythagorean theorem doesn't work unless there is that 90 degree there and it's a right triangle. Okay, so this is a right triangle. I can solve for a missing side length if I have two other sides. Okay, so it's really important to get the A, B, and C part correct, and I haven't labeled them yet. I'm going to do that in a second. So A, B, and C are just going to be numbers, and they're going to represent the sides of this triangle. So where do they go? It turns out that A and B are just the two legs of the triangle, and C is the hypotenuse. And the hypotenuse is the longest side in a right triangle because it's across from the longest angle. And so you can see right here that C is right there, okay? And that's because it's right across from this 90-degree angle there, okay? So straight across is the longest side. C has to go there, that longest side, all right? And A and B are just the other two sides. And it doesn't matter exactly where. I usually go left to right. So I'll label this one as A and I'll label this one as B. And that's your generic triangle, okay? Now, if I were to take this triangle and move it and rotate it and make it look a little different, it doesn't change where C goes. Okay, so C is always going to be across from that 90 degree. There's the bell. So I'm going to keep moving this around and rotate it just to show you sometimes the orientation of the triangle is turned around and you have to look for that 90 degree to find where C would go. Okay, and that will help you when solving for X. All right, and in fact, we're going to do a problem where we would have to solve for X. So let me change this up a little bit. And let's say that we are trying to find the hypotenuse is X, let's say. Let's just make up a problem. And we're going to label the other two sides. So at this point, I cannot solve for X until I have some other information. So let's make this side 3 and this side 4. And I'm not even going to put units on there. I'm just going to keep it really straightforward. So how would I use the Pythagorean theorem? Well, first thing I want to do is I want to label that A, B, and C, just like I had before. So A is going to be this side, B is going to be this side, and C is going to be this side. And remember, I'm using A squared plus B squared equals C squared. So what does that mean? What is that going to look like? Well, if I have the formula A squared plus B squared equals C squared, I'm just substituting in the values that I have. So A is 3, so it's going to be 3 squared plus B squared, which is 4, so 4 squared, equals X squared, okay? So I just substituted in from what I saw. Now all I need to do is square those items. So 3 squared, what that means is 3 times 3. So that's going to be 3 times 3, which is 9. And you could always use a calculator for that. And then 4 squared, 4 times 4, right? 4 squared is 16, okay? And then that equals X squared, all right? So I can't do anything with X yet. 9 plus 16, I can combine those. I can combine 9 plus 16, and if you want to use a calculator, you can. 25, that's what it equals. And now I have 25 equals X squared. So some people will get kind of stuck here because this is another new thing, potentially. You haven't seen this since algebra. To get rid of the squared part, and that squared part is this little guy right there. That's the squared part. I need to undo that. And in order to undo that, I'm going to do something called take the square root. So I'm going to take the square root of 25 and the square root of X squared. When I take the square root of X squared, they annihilate each other. It undoes the squaring, leaving me with just what X equals. And you can use a calculator to figure out what the square root of 25 is if you don't already know. It's 5 because 5 times 5 is 25. Now in algebra, we would say X is 5 or negative 5. Right now in geometry, since we're talking about a real triangle, we're just going to leave it like that. So it turns out x is exactly 5 in 5 units, whatever that may be. All right, so there's our answer for that. And in this problem, we didn't run into too many issues because all the numbers were on the left side of the equal sign, and then x was on the right side of the equal sign. Let's look at one more example where that doesn't happen, where x ends up in a different spot. And I'm using easier numbers so that this becomes easier for us, all right? So let me try to draw another problem here. Let me try to draw this triangle in a little bit of a different way. Let's see if this works. Okay, so there's my terrible triangle. I might try that again, actually. I'm gonna draw my triangle. All right, make sure it's a right triangle, okay? And I'm gonna throw some measurements in there. So I'm gonna make this one 5. I'm gonna make this one x, and I'm gonna make this one 13, all right? And I wanna solve for x. That was the instruction, solve for x. And I wanna use that Pythagorean theorem, and it doesn't change every single time. What did change in this problem is the fact that c isn't x, okay? Remember, c is this longest side out here. It's across from this 90-degree angle. That's the longest side in our right triangle. And then a and b are just our other two sides. So in this case, b was x. And I'm gonna fill that in. So a was 5, so that's 5 squared, plus b was x, so that's x squared, equals c squared, so that's 13 squared. And you can already see that in our first example, all the numbers were on the left side. And in this example, we've got numbers and x's combined. So you won't be able to just plug in x squared in the calculator. It doesn't know what x is. So you have to do some different strategies. The one thing that remains the same, though, is I'm going to be squaring the 5. So 5 times 5, which is 25. And I'm going to leave the plus x squared there, and I'm going to deal with that in a second. And that equals 13 squared, so that's 13 times 13. Calculate, you get 169, okay? And at this point, again, this is a little bit different than the previous one, a little bit of a different style because x wasn't where c was. So what I have to do is I have to get all of the numbers on one side of the equal sign. So I've got two sides of the equal sign. I got the left side and I got the right side. I got to move all the numbers to one side. So I'm going to subtract 25 here from the left side and from the right side so that the 25 minus 25 becomes 0. And I'm just going to be left with x squared on the left side of my equal sign. And then I have to do the math. 169 minus 25. Calculate. You can use a calculator. You get 144. Okay? And that is the different step in this one, right? So previously, I could just add those together. In this one, I had to subtract to get it all on the same side. And now I'm going to take the square root of both sides, and I'm going to get x equals the square root of 144. It turns out that that is a nice clean number. That is just 12, and that's 12 units. Again, this is a real triangle, so we're not going to do the positive and negative version. X equals 12 is our answer there. There are some other pieces to look at when you do these problems, like units and rounding, but for right now, this is the basics on how to get these answers. And I certainly hope that that video helps. See ya.